The single most destructive bug in an autonomous AI system is the infinite loop. It tries a task, fails, and immediately tries again. This occurs when an agent's logic fails a goal but lacks a strict exit condition. Every attempt calls the language model. Every call consumes tokens, and every token costs money. When traditional software encounters a fatal logic error, it crashes and stops. An AI agent loop continues to run, actively spending capital with every iteration. An unchecked loop functions as a runaway financial engine, capable of draining an enterprise budget in a single night. Engineering teams prevent this by using a mandatory debugging framework known as the STEP protocol. The S sets hard caps, establishing a strict limit on allowed iterations. T stands for trace the logs, maintaining total visibility into the agent's decision tree. E ensures state changes, confirming actual progress occurs. Finally, P probes exit conditions, guaranteeing the software stops. Implementing the STEP protocol shifts AI from unpredictable probabilistic guessing into bounded, auditable engineering. Even with perfect internal logic, an AI agent remains exposed to the outside world. Agents connect to external databases using application programming interfaces, or APIs. These data bridges represent a primary structural vulnerability. If an external API server crashes or times out, an agent can experience hallucination under duress. Lacking real data, the AI fills the void with fabricated information. Attackers deliberately target and overload these external connection points to feed the agent corrupted data and disrupt its reasoning. An autonomous system is only as secure as the weakest external tool it holds. In 2026, an enterprise experienced this firsthand when it deployed an unguarded procurement agent to handle supplier logistics. Attackers manipulated an external pricing database. When the agent tried to verify the mismatched data, it became trapped in an unchecked execution loop. The agent efficiently generated thousands of fake purchase orders, racking up $5 million in fraudulent charges in a matter of days. Standard system instructions telling the AI to be careful with budgets failed. The agent ignored the prompt, convinced it was following the correct procedure. Granting an AI financial autonomy without hard-coded external limits creates an uncontainable blast radius. Engineers solve this by using a mechanism borrowed from the electrical grid, the software circuit breaker. This code acts as a monitor between the agent and the internet. It watches specifically for API connection timeouts or repeated hallucinations. The trigger condition is strict. If an external connection fails 3 consecutive times, the system reaches its limit. At 3 strikes, the circuit mechanically opens. It immediately and completely severs the agent's connection to the outside world. The circuit breaker creates a deterministic boundary that isolates external chaos before it reaches the internal network. When the circuit breaker trips, the system must determine the next step for the workflow. This diagram illustrates the fallback chain. Instead of crashing the entire platform, the architecture gracefully degrades. The blocked workflow drops from the vulnerable external model down to a secure local cache or a restricted internal network. This leads to the definitive law for 2026 enterprise deployment: design for failure from day one.